সকলের হয়ে গেছে, পাঠিয়ে দিয়েছিস? সকলের হয়ে গেছে, পাঠিয়ে দিয়েছিস? So today we are going to start a new chapter, that is acid, base and salt. The syllabus contains simple definition of acids and bases in terms of their molecules, their characteristics, properties, what are the ions present in different types of acids, alkalis and salts, taste of acids or alkali with pH paper or litmus paper, the acid base strength also, which is known as actually acidimetry and alkalimetry, different types of salts, and the action of acids on those salts, and also the methods of preparation of different salts using different types of methods. So first of all, we should discuss what is actually acid. The acid, this term comes from the citrus fruits. That is, citrus fruit, those are acidic. It contains citric acid, and the term acid is derived from a Latin word which means sour. So acids are generally, initially it is assumed that all the acids should be in sour in taste, but acids have definite some of the physical and also some of the chemical properties that can be used to identify the acids. And also if you consider the different types of acid, natural acids, like this is vinegar. Vinegar is not oxalic acid, that is acetic acid. Here it is tartaric acid, and in tomatoes it contains the oxalic acid. These are some important naturally occurring acids. Those acids are coming from living organisms, that is, some of the acids coming from plants or some of the acids coming from animals. Now if you consider the alkalis, then alkalis or bases, they are bitter in taste. And also they have some of the uses, like they are used to prepare soap or some detergent powder, even some baking powder, etc. So both acids and bases have their own applicability. Here you see some metallic oxides and hydroxides. Those are actually known as bases. Like if you consider sodium oxide or even sodium hydroxide, they are called bases. Generally metallic oxides and hydroxides, they are actually bases. Now when acid added into water, then acids generally produce hydrogen ion. And this hydrogen ion get attached to water with the formation of hydroxonium. This is hydroxonium ion. So acids are those which can give H plus ion or hydroxonium ion. Hydroxonium or oxonium ion, you can say oxonium ions. Those are called generally acids. But there are so many definitions are there. Those definitions are according to some of the definition according to Arrhenius, some given by Bronsted Lowry, some given by Lewis. So acids and bases have so many different types of definitions. Now, first of all, we should see that the acid is a compound which, when dissolved in water, acid is such a compound that when dissolved in water, it yields a hydronium ion, or even you can say hydroxonium ion. When acid is a compound which, when dissolved in water, has the only positively charged ion. For example, if you consider hydrochloric acid, HCl. HCl, when added into water, then HCl produce H plus, and that H plus get attached with water with the formation of hydroxonium ion and Cl minus. So here you see that only positively charged ion is hydronium ion. So acid should be HCl, because of the fact that HCl gives H3O plus in aqueous solution. That's why HCl is termed as acid. So this is the definition of acid. So acid is such a compound which, when dissolved in water, it yields hydronium ion H3O plus as the only positively charged ions. Here you see what happens when a hydrochloric acid HCl is added into water and why. Now HCl, where hydrogen is covalently bonded with other chlorine atom. This is important. Hydrogen is get attached with chlorine atom through covalent bond. This is covalent bond. Covalent bond. But because of the fact that electronegativity of chlorine is much greater than that of electronegativity of hydrogen, so the bonded electron pair attracted towards the chlorine atom. So this type of covalent bond is known as polar covalent bond. Polar, what we should say? Polar covalent bond. So when HCl is present in this way, that chlorine draws electron pair towards itself, creating slightly negative charge over chlorine atom and slightly positive charge over hydrogen atom. So because of the fact that HCl molecule has some polar character means the negative and the positive, that is called polar. So when HCl dissolved in water, the water is also a polar solvent because it contains electronegative oxygen atom and electropositive hydrogen atom. So when HCl dissolved in water, then the oxygen atom present in water, it attracts the hydrogen part of HCl, because hydrogen is positive and oxygen is negative. So there is some sort of electrostatic attractive force between water and hydrogen. On the other hand, the hydrogen part of water, which is actually electropositive, it attracts the chlorine atom, and as a result, this hydrogen chloride breaks and H plus and Cl minus separated from each other, though it is a covalent bond, but H plus and Cl minus separated due to its polar nature. So HCl ultimately converted into H3O plus and also Cl minus. So this is the process how HCl dissolved in water. So repeating again, HCl is a covalent molecule, and because of the fact that chlorine is much more electronegative with respect to the hydrogen, so chlorine draws electron pair towards itself, creating slightly electronegative character over chlorine and slightly electropositive character over hydrogen. Now, when HCl is added into water, then water is also a polar solvent, because in water oxygen is electronegative and hydrogen is electropositive. So water is also polar and HCl is also polar. So polar solute always dissolved in polar solvent. Here you see that HCl when added into water, then the hydrogen part of the HCl, that is attracted by oxygen part of water, and chlorine part, that is attracted by the hydrogen part of water. And after that, HCl bond between H and Cl, that is breaks with the formation of H plus, that ultimately leads to the formation of H3O plus and Cl minus. That's why when HCl is added into water, it shows its acidic behavior. Is it clear why HCl shows acidic behavior in water? Is it clear to you? Bodhikrit,
Yes, sir.
Nirav,
Yes, sir.
okay, Boidirjo.
Yes, sir.
Okay, so HCl is acidic character. HCl having acidic character. So just consider in this way uh, that a test tube where the HCl gas is evolved. This is HCl gas, and a dry litmus paper that is held into the HCl gas. If you use dry litmus paper, like dry litmus paper having color blue, so it does not change any color of the litmus paper, because dry HCl gas is not acidic in character. Unless and until HCl is dissolved in water or HCl in presence of moisture, that only behaves like acid. So HCl gas, that is the HCl gas, is not acidic in nature, only because of the fact that HCl shows its acidic property only when dissolved in water. Because when HCl dissolved in water, it produces H3O plus and Cl minus. That's why HCl when dissolved in water, it produces H3O plus, and then it shows acidic character. Now, what is base? Base is a compound which reacts with hydronium ions of an acid to give salt and water only. Suppose you consider that Na2O, it is a base. It when reacts with like HCl, it contains hydronium ion. It reacts with hydronium ion with the formation of salt and water. So base is such a substance that reacts with acid. Actually, it reacts with acid, the formation of salt and water. So base is such a compound which when reacts with hydronium ion or the acidic substance to give salt and water only. Now, cupric oxide is a base. So what happens when cupric oxide is react with HCl? Cupric oxide reacts with HCl with the formation of CuCl2 and water. This one is salt and this one is water. Also the copper hydroxide, this is also base, and when reacts with sulfuric acid with the formation of copper sulfate and water. So copper hydroxide, copper oxide, all these are bases, and they react with acid with the formation of salt and water. So bases are those substances which when reacts with acid produces salt and water. So bases are generally oxides and hydroxides of metal. Exceptional That is the ammonium hydroxide. Ammonium ion is metal-like. Ammonium ion is positive radical, but not metal. Positive radical. Positive radical. So ammonium hydroxide is also considered to be base, and other oxides and hydroxides of metal like sodium oxide, sodium hydroxide, or magnesium oxide, magnesium hydroxide, etc. All those compounds are considered as base. So the bases which are soluble in water, the bases, oxides, hydroxide, which are soluble in water, if you add water, if it is soluble, then that base is termed as alkali. So what are alkali? When bases soluble in water produces a clear solution, then that type of base is also termed as alkali. If bases are not soluble in water, those are considered as base but not alkali. Like some of the examples of insoluble bases which are not alkali, which are not alkali. So bases, those are soluble in water. Bases, those are soluble in water. They are base as well as alkalis. But if the bases are not soluble in water, they are insoluble, then they termed as base but not alkali, like zinc oxide, lead oxide, copper oxide, or ferrous hydroxide, ferric hydroxide, lead hydroxide, cupric hydroxide. These are some of the compounds which are they are base, but they are not considered to be alkali because those compounds are not soluble in water. So all the alkalis are bases. All the alkalis are bases, but all the bases are not considered to be alkalis because some of the bases, they are not soluble in water, and that's why they are not considered as alkali. So here you see zinc oxide. Zinc oxide is a base, but zinc oxide, when dissolved in water, it produces zinc hydroxide, and zinc hydroxide is not soluble in water, it is insoluble in water. That's why zinc oxide should be termed as base but not alkali, only because of the fact that zinc oxide is insoluble in water. Same thing like lead oxide or copper oxide or ferrous hydroxide, etc. Those are insoluble bases but not alkalis. Okay. Now, what is alkali? What is alkali? An alkali is a compound. Alkali is a compound which, when dissolved in water, it produces hydroxyl ion, OH minus ion, as the only negatively charged ion. For example, if you consider sodium hydroxide, sodium hydroxide is an alkali. That's why sodium hydroxide is easily dissociated with the formation of Na plus and OH minus, because of the fact that sodium hydroxide gives OH minus as the only negatively charged ion. That's why sodium hydroxide is termed as alkali. So alkali is such a compound. Alkali is such a compound which, when dissolved in water, it must be dissolved in water. So primary criteria of any alkali is it must be dissolved in water. It must be the metal hydroxide also, but it must be dissolved in water, and it should produce the hydroxyl ion as the only negatively charged ion. So here you see that sodium hydroxide, when dissociates, the formation of Na plus and OH minus. That's why you can say that sodium hydroxide is an alkali. Is an alkali only because of the fact that it gives rise OH minus in solution, and that's why sodium hydroxide is an alkali. So here you see sodium hydroxide produces Na plus and OH minus. Again, bases, already we have mentioned that bases, those are water soluble. Water soluble bases are alkalis. So all the alkalis are bases, but all the bases are not alkalis, because some of the bases, those are insoluble. Some of the bases, those are insoluble, and they should not be considered as the alkali. And that's why you can say that all the alkalis are bases, but not all the bases are not alkalis. For example, like copper hydroxide. Copper hydroxide is a base because it is a metal hydroxide. It must be considered as base. But this copper hydroxide, when you add it into water, this copper hydroxide is not soluble in water, it is insoluble. And that's why it should not be considered as alkali. Copper hydroxide should not be considered as alkali. But copper hydroxide is a good base. That's why you can say that alkalis are bases. All the alkalis are primarily bases, but not all the bases should not be considered as alkali. So this is all about the definition related to the acids and bases and alkalis also. There are some examples of alkalis given over here, like potassium hydroxide, sodium hydroxide, calcium hydroxide, ammonium hydroxide. These are the alkalis, because all those compounds, they are soluble in water, and also they produce OH minus in aqueous solution, and that's why you can consider that potassium hydroxide, sodium hydroxide, calcium hydroxide, ammonium hydroxide as the alkali. Now, when sodium hydroxide is added into water, what happens that sodium hydroxide is a highly ionic compound and it easily dissociates with the formation of sodium hydroxide, sodium plus and OH minus. This is the dissociation of sodium hydroxide in water, where sodium plus and OH minus produces. Again, potassium hydroxide dissociation is quite similar to that of sodium hydroxide. Potassium hydroxide dissociates the formation of K plus and OH minus. This is also the similar dissociation, just like sodium hydroxide. And also the calcium hydroxide, because of valency of calcium is 2, so calcium hydroxide dissociates with the formation of calcium 2 plus 2OH minus. So in this way, this type of alkalis, they dissociate in water with the formation of the OH minus, which is the only negative charge ion in aqueous solution. Ammonium hydroxide is not a metal hydroxide, but ammonium ion is a positively charged ion, ammonium hydroxide. It dissociates with the formation of NH4 plus OH minus. Though ammonium hydroxide is a very weak alkali, but it dissociates the formation of NH4 plus and OH minus. Now we discuss about the classification of acids. Now, classifications of acids and bases, they can be considered on the basis of several different criteria, like depending upon their sources, from which source those acids you prepare, from which, depending upon the source, depending upon the strength of the acids, depending upon the concentration, and also the depending upon the molecular composition. So there are the 4 different types of classification. There are so many other types of classifications are there, but so in case of classification of acid, first of all, we classify the acid on the basis of their sources. Now, on the basis of their sources, there are 2 types of acids. One is known as organic acids. Organic acids, those are usually obtained from plants or animals, that is from the living organism. Those acids are usually obtained from plants or animals, generally plants, and they most of the time contains carbon, but carbonic acid that contains carbon, but this acid should not be considered as organic acid. uh, most of the organic acids, that need not mean all the carbon containing acid should be considered as the organic acid, but most of the organic acid, they are generally contains carbon, and the source of those acids are living organism like plants and animals. Here some of the examples, like already we have mentioned that oxalic acid that is present in guava or in tomatoes, or acetic acid that is present in plants, plant extraction, that is acetic acid. So depending upon the sources, some of the acids, those are termed as the organic acids. Now there are some acids which are generally considered as the inorganic acid. Now inorganic acids, though, those are generally obtained from minerals. They do not contain carbon. They generally do not contain, except carbonic acid. We already mentioned that carbonic acid, it is a carbon containing acid, but it is inorganic acid. So these acid usually obtained from the minerals, like all those acids, important acids like sulfuric acid, like nitric acid, like hydrochloric acid. For example, nitric acid. If you consider nitric acid, then nitric acid is obtained from nitrate salt, or the hydrochloric acid, that is obtained from chloride salt or potassium chloride, or sulfuric acid, those are obtained from sulfate salt. So these are some important inorganic acids. Inorganic acid, those are generally obtained from the minerals. Now, depending upon the strength of acid, strength of the acid, strength means the how much H plus or the H3O plus ions produced from acid when dissolved in water. So strong acid means they are near about complete. If you consider sulfuric acid, now sulfuric acid, it near about totally dissociate 100%, near about 100% dissociates the formation of H plus and SO4 2 minus, and that's why it is undissociated form of sulfuric acid becomes very less, and that's why these acids produce more number of H plus or H3O plus ions when dissolved in water. It produces a greater number of H plus ions, and that's why these acids are termed as the strong acid, like hydrochloric acid, sulfuric acid. Most of the inorganic acids are considered as the strong acid. So these acids produce more number of H plus, and they completely dissociate, completely near about completely dissociate with the formation of H plus ions. So strong acids, strong acids dissociates completely in aqueous solution, thereby producing high concentration of H plus ion or H3O plus ion. Concentration means the how much mole amount per liter. This is known as concentration. Concentration. What is the amount of H plus per mole? H plus in mole concentration. So mole of H plus per liter of the volume of the solution, overall volume of the solution, is known as concentration. So strong acid dissociates near about completely uh, with the formation of high concentration of H plus ions or H3O plus ions. These are called as strong acid. For example, sulfuric acid. Sulfuric acid, when dissolved in water, it produces sulfuric acid. It initially dissociates to give single H plus and HSO4 minus. HSO4 minus. Okay. HSO4 minus. Now in the second step, HSO4 minus, It again dissociate with the formation of H plus and SO4 2 minus. So after adding these two, H2SO4 2H plus SO4 2 minus. So dissociation of sulfuric acid dissociates in aqueous solution in this way. Single molecule of H2SO4 gives two H plus ions. Again, if you consider nitric acid dissociates with the formation of H plus and NO3, H plus and NO3 minus. So it gives only one H plus per molecule of nitric acid, but high concentration nitric acid near about totally dissociates the formation of H plus and NO3 minus. Now, weak acid. Some acids are considered as weak acid. Weak acid means they are incompletely dissociates to give H plus ions when dissolved in water. Suppose acetic acid. Acetic acid is considered as weak acid because when it dissociates, this process is reversible. That's why we use this type of symbol. Acetic acid when dissociated, it produces H plus and CH3COO minus. This is incompletely dissociate. Most of the acetic acid present as undissociated form, and very less number of H plus ions produces in this process. That's why you can say that acetic acid is a weak acid. Again, carbonic acid is another example. Now most of the organic acids are considered as the weak acid. Carbonic acid, though it is inorganic acid, but it is also weak in character. Carbonic acid is also weak in character. So these are the classification of acid on the basis of their strength. Now acetic acid, how acetic acid dissociate, we already mentioned that how acetic acid dissociate. This is acetic acid, CH3COOH. Though it contains so many number of hydrogen atoms, here contain hydrogen atom, here 3 hydrogen atom. But all those 3 hydrogen atoms, they are not acidic. Only those hydrogen atom get attached to its electronegative atom. Hydrogen, those attached to electronegative atom like oxygen, it is acidic in nature. So when acetic acid dissociate, it produces acetate and H plus. Again, carbonic acid, this is H2CO3. It when dissociates, it produces CO3 2 minus plus 2H plus. CO3 2 minus and 2H plus. Now formic acid, do you know what is the formula of formic acid? Anyone? What is the formula of formic acid? Do you know? What is the formula of formic acid? Boidurjo?
HCOH.
Very good. HCOOH is formic acid. Formic acid. Now this HCOH, formic acid, when dissociate HCOH, is formic acid. When dissociate, it produces HCOO minus and H plus. So there are some dissociation of weak acids where the acids are considered as weak acid, and those weak acids, they are incomplete dissociate the formation of respective ions with H plus. anhydrous acetic acid, one important information, this is important information, that anhydrous acetic acid on cooling, it forms the crystals of glacial acetic acid. It looks like glacial or ice-like. So acetic acid on cooling shows uh, its nature, or it, it is converted into crystal-like structure, which is actually looks like glacial. That's why it is termed as glacial acetic acid. Now, strength of an alkali depending upon the concentration of OH minus. So, if an alkali gives large concentration of OH minus in aqueous solution, it is called as strong alkali. It is called as strong alkali. So, strong alkali, some of the strong alkali like sodium hydroxide, potassium hydroxide, all the alkali metal hydroxides, they are very strong alkali. It is an alkali which dissociates in aqueous solution almost completely, and thereby producing a high concentration of high concentration of hydroxyl. So strong alkali means it is an alkali when dissociates in aqueous solution almost completely, and thereby producing high concentration of hydroxyl ion. So strong alkali are those, they are near about totally dissociates, giving the high concentration of OH minus, giving the high concentration of OH minus. Like lithium hydroxide easily dissociates with the formation of lithium plus ion and OH minus ion. Here is the dissociation of lithium hydroxide. There is no reversible nature, only because of the fact that lithium hydroxide is strong alkali. So lithium hydroxide, lithium plus OH minus. Similar dissociation in case of sodium hydroxide also, sodium plus and OH minus, and also in case of potassium hydroxide. All those three alkali metal hydroxides are strongly alkaline in nature because they dissociate near about totally. They dissociate near about totally uh, to form high concentration of OH minus. That's why they are termed as strong alkali. Weak alkali, similar that of weak acid, they partially or incompletely dissociate, producing low concentration of hydroxyl ion. Like ammonium hydroxide. Ammonium hydroxide is weak alkali. It dissociates a very low concentration of OH minus. That's why it is termed as weak alkali. It's termed as weak alkali because partially dissociates, not totally, partially dissociates very less concentration or low concentration of OH minus, like ammonium hydroxide or even calcium hydroxide. Ammonium hydroxide already mentioned. Calcium hydroxide, CaOH whole 2, it dissociates. When you dissociate any weak alkali or weak acid, use this type of reversible sign, because in those cases the products again unite with the formation of undissociated molecule. Yeah, calcium 2 plus 2 OH minus. So depending upon the strength of acids or alkali, there are two different types of acids or alkali. One is strong, another one is weak. Now, if you want to compare the acidic character of different acids, then it is not sufficient to consider them as strong acid and weak acid. Just think about the fact that when a particular acid when a particular acid dissociate totally or near about totally, then that acid or base should be termed as strong acid or base. But other acids or bases which are not totally dissociates should be termed as weak. But there are so many number of weak acids are there. For example, acetic acid is weak, and formic acid is also weak because acetic acid is not 100% dissociated. Formic acid is also not 100% dissociated, so both acetic acid and formic acid is weak. But can you consider out of this formic acid and acetic acid, which one is a stronger relative strength, which one having greater strength with respect to the other? You can't say. Only because of the fact that you have only two categories. One is a totally dissociated, that is 100% dissociated, and another one is a less than 100% dissociated. So one is strong and another one is weak. But here we have some different quantities like degree of ionization, that is alpha. The degree of ionization value gives us an idea that out of those different weak acid, which one is weakest and which one is weaker. That can be considered on the basis of the fact that degree value, that is the degree of ionization, where it is the ratio of number of acid molecules ionized divided by total number of acid molecules present in the aqueous solution. If you take 100 molecules in aqueous solution and out of those 100, the 50 molecules are dissociated, then degree of dissociation will be 50%. So you can compare the acetic acid or formic acid on the basis of degree of ionization. If you consider that the degree of ionization of acetic acid is greater with respect to the degree of ionization of formic acid, then acetic acid is comparatively more acidic than that of formic acid, though it is considered that both acetic acid and formic acid are weak acid. But if a particular acid is near about 100% dissociated, that should be termed as strong. But if an acid having 50% dissociated, that is called as weak. When it is 10% dissociated, it is also called as weak. When 80% dissociated, theoretically it is also called as weak. So 80% dissociation and 10% dissociation is not the same. So when you get the information about the degree of ionization, then you can compare the relative strength of the weaks also. So weak acids or weak bases, they can be compared on the basis of such a factor that is known as degree of ionization. So which is the ratio of number of molecules that acid or alkali, maybe whatever might be, the number of molecules ionized divided by total number of molecules present in the aqueous solution multiplied by 100. Now, depending upon their concentration means what is the amount of the acid is present in water. What is the amount of acid present in water? There are two types of acids or bases on the basis of their concentration. That is number one, concentrated acid, and number two, dilute acid. Now, what is concentrated acid? Concentrated acid means that type of acid contains very less or negligible amount of water. Mostly it contains the acid, like 98% sulfuric acid. When you consider the 98% sulfuric acid. Now, what is that? 98% sulfuric acid. That means that it contains 98 parts sulfuric acid and only 2 parts of water. This is very strong. This is concentrated acid. So in this way you can compare the concentrated acid and the dilute acid. What is dilute acid? Is dilute acid. It is having acid having low percentage of acid in aqueous solution. If an aqueous solution contains the large volume of water with a very small amount of sulfuric acid or nitric acid, etc. If you add 2 to 3 ml of acid in 1 liter of water, then it is considered to be very dilute solution. So dilute and concentrated solution should be considered on the basis of how much amount of acid or base is present in a certain volume of water. If the amount of acid is high, then it is considered as the concentrated acid, or if it is less, then it is dilute acid. Similar is the thing that is the concentrated alkali. Concentrated alkali means it contains high percentage of alkali, and dilute alkali means it contains a very small amount of alkali in aqueous solution. Concentration is less than 1 mole per liter. This is just quantitative idea, that is 1 mole per liter of acid or base less than that quantity is considered to be dilute. We have already mentioned that concentration always expressed as mole per liter. How many moles present per liter of the solution? Now another type of classification, that is depending upon the molecular composition. Now what are the atoms, what are the type of atoms present in acids? There are two types of acids on the basis of their molecular composition. One is oxyacid. Oxyacid means it contains always contains it contains oxygen, hydrogen, and another non-metal. That is actually known as oxyacid. It contains oxygen along with hydrogen and some other element. Some other generally non-metal elements should be present. They are called as oxyacid. They are called as oxyacid. So oxyacids like nitric acid, sulfuric acid, etc., they are called oxyacid. Phosphoric acid too, they are called oxyacid. Now a hydracid, another type of acid, that is hydracid. Hydracid means it contains hydrogen and some other non-metal, but no oxygen. There must not be oxygen present in this case. So this type of acids are known as like hydrochloric acid, HCl, simply HCl, or you can say HF, or you can say HBr. This type of acids should be termed as hydracid. They are known as hydracid. So depending upon the molecular composition, there are two types of acid. One is oxyacid and another one is hydracid, like HCl, HBr, HI, etc. Now the last one that we classify on the basis of their basicity. Basicity, depending upon the basicity, acids can be classified into different ways. Now what is basicity? Actually, what is the term basicity means? The basicity means per molecule of the acid gives how many number of H plus ions. For example, like H2SO4. This is one molecule, and H2SO4 dissociates with the formation of H2H plus and SO4 2 minus. So one H2SO4 molecule that gives two H plus ions. So basicity of H2SO4, basicity of H2SO4 is actually, basicity of H2SO4 is 2. How many H plus ion produced from a single or one molecule of the acid in aqueous solution? Here you see that H2SO4, it gives two H plus ions from single molecule of H2SO4. That's why basicity of H2SO4 is 1. So on the basis of basicity, in case of acid, the term is basicity of acid, but in case of base, the term is acidity of base. Now the definition is quite similar. That is, how many number of hydroxyl ion. For example, if you consider calcium hydroxide, then one molecule of calcium hydroxide, it dissociates the formation of calcium 2 plus and 2 OH minus. So it gives rise to OH minus from one calcium hydroxide, and that's why the acidity of calcium hydroxide is 2. Acidity. So in case of acid, the term is basicity, and in case of base, the term is acidity. So acidity of calcium hydroxide is 2, but acidity of sodium hydroxide is 1. So number of hydroxyl ion which can be produced per molecule of the base in aqueous solution, the number of hydrogen ion with which the molecule base combines. Now, the monobasic acid, some acids are known as monobasic acid. Monobasic acid means it gives only one H plus per molecule of acid. Like H2SO4, like HNO3, like HF, it gives only one H plus per molecule of acid. Then it is known as monobasic. Mono means one. Monobasic acid, HCl, HNO3, not H2SO4. H2SO4 is dibasic. So HCl, when dissolved in water, it is monobasic. So HCl, when dissolved in water, it produces H3O plus Cl minus. So dissolution of HCl in water. Dissociation of acetic acid, it contains so many number of H plus H, but only one H is dissociated to the formation of CH3CO minus and H plus. All those three hydrogen atoms are not acidic. So CH3CO minus plus H plus. This is hypophosphorus acid. Now see, hypophosphorus, what is the formula of hypophosphorus acid? That is H3PO2. This is hypophosphorus acid. There are three different types of phosphoric acid. One is H3PO4. This is phosphoric acid. H3PO3. This is phosphorus acid. This is phosphoric. Phosphoric. This is phosphorus acid. Phosphorus acid. And H3PO2 is hypophosphorus acid. Has only it has one basicity is 1. Hypophosphorus acid, when dissociates, hypophosphorus acid H3PO2, when dissociates, form H plus and H2PO2 minus. So hypophosphorus acid gives only one H plus per molecule of acid. That's why it is monobasic. It is monobasic. Nitric acid also dissociate H plus NO3 minus. These are monobasic. Now we consider the dibasic. Dibasic, already we have mentioned that sulfuric acid is dibasic because one molecule gives two, one molecule gives one molecule one molecule of sulfuric acid gives 2 H plus ion. Like carbonic acid is similar, H2CO3, 2H plus plus CO3 2 minus. They are all considered as dibasic. Some of the organic acid like oxalic acid, this is oxalic acid. This is dibasic, CO minus, CO minus plus 2H plus. It gives 2H plus from single molecule of acetic acid. So it is dibasic. Dissociation of sulfuric acid, already we mentioned. Dissociation of sulfurous acid. Sulfurous acid having formula H2SO3. H2SO3. It when dissociates, it produces SO3 2 minus plus 2 H plus. This type of dissociation, that is a sulfurous acid. Sulfurous acid. And this is oxalic acid, already mentioned, COOH. COOH dissociated CO minus plus 2 H plus. Carbonic acid, already mentioned. Tribasic acid, that means one single molecule gives 3 hydronium ions, 3 hydronium or 3H plus ions, like phosphoric acid, H3PO4. It gives 3H plus ions, 3H plus ions in solution from one molecule of phosphoric acid. Now, in case of bases, that is monoacidic base. Monoacidic base means it gives only one OH minus. It gives only one OH minus, like this. Ionizes in aqueous solution, produces one hydroxyl ion, one OH minus per molecule of the base. Is known as monoacidic base. Like sodium hydroxide, potassium hydroxide, all those are known as monoacidic base. Again, sodium hydroxide dissociate with the formation of Na plus and OH minus. This is monoacidic base. Or potassium hydroxide dissociate with the formation of K plus and OH minus. This is also monoacidic base because only one OH minus is produced from one molecule of sodium hydroxide. Ammonium hydroxide is also monoacidic base because one ammonium hydroxide gives one OH minus. Diacidic base, the base which dissociates in aqueous solution giving 2 OH minus per molecule, diacidic base. Like ionization, 2 hydroxyl ion molecules per molecule of the base. One molecule of the base gives 2 hydroxyl ions. Like calcium hydroxide, if you consider calcium hydroxide dissociates. Calcium hydroxide, CaOH whole 2, dissociates with the formation of calcium plus 2 OH minus. So these are diacidic base. Cupric hydroxide, it is also diacidic because cupric hydroxide dissociates with the formation of copper 2 plus plus 2 OH minus. Cupric hydroxide. Like calcium hydroxide is also diacidic base. Calcium hydroxide one molecule of calcium hydroxide gives 2OH minus. Triacidic base. It is the only example. It is the aluminium hydroxide, AlOH whole 3 dissociates aluminium plus 3 plus 3OH minus. So all these are example and definition. So informative this part. Uh, so in ionizes in aqueous solution to produce 3 hydroxyl ions, triacidic base. For example, aluminium hydroxide. Already we have mentioned that aluminium hydroxide is such a compound that one molecule of aluminium hydroxide gives 3 OH minus ions. Like ferric hydroxide, it is also triacidic base. Ferric iron plus 3 OH minus. One molecule gives 3 OH minus. So this is all about the classification. Phosphoric acid can form 3 types of salts only because of the fact that phosphoric acid had triacidic base, tribasic acid. So when it dissociates with the formation of H2PO4 minus plus H plus, it forms a salt with sodium hydroxide NaH2PO4. Now H2PO4 minus again dissociate the formation of HPO4 2 minus plus H plus. So HPO4 2 minus, it reacts with sodium hydroxide, produces Na2HPO4. Now HPO4 2 minus dissociates with the formation of PO4 3 minus plus water. So PO4 3 minus on sodium hydroxide produces Na3PO4. So 3 different types of salt can be prepared from phosphoric acid, that is sodium dihydrogen phosphate, disodium hydrogen phosphate, sodium phosphate. These are the different types of salts. Those are produced from phosphoric acid. So this is introductory part, that is the classification already we have completed. Now after that, next day we should discuss the Arrhenius theory, Bronsted-Lowry concept, etc. Those theories of acids and bases. So today we up to this. Next day we should continue this particular chapter, Arrhenius theory, and the pH concept, most important part. Next day we should discuss, that is the pH of acids and bases. So conception about pH we discuss. So আজ বাস ইতনাই, পরের দিন আবার দেখা হবে রাত্রিবেলা। ওকে, থ্যাংক ইউ, গুড নাইট সবাইকে।
Thank you, sir. Good night, sir.
গুড নাইট,
Bye, sir.
বাই।